Devoxx US so far? Cool. All right. So I was asked to put together this presentation. This originally wasn't scheduled, so they wanted to put on a second deck around CDI 2.0. So I decided to split things between CDI 2, the new and the noteworthy features, as well as a separate CDI 2 topic Thursday, 2:50, to talk about CDI in an SE environment. So a little bit about me. CDI, I'm a member of the CDI expert group along with Emily. A few other things that I've worked on. And I can't. Okay, there we go. So one of the things to point out is the CDI spec is always growing. We are an Apache 2 licensed specification, one of the few that are out there. Because of that, we're always taking community input, and we want to build on top of the open source community. We do have a dedicated website, cdispec.org. We did just complete our public review ballot as well. So you can go out, you can see what we are actually reviewing, and I believe by April, we're going to have the CDI 2 final specification out there for public consumption. Weld 3 is in the CR state, so you can leverage that today if you're looking to experiment with some of the new features in CDI 2.0. They are actively available as a patch for Wildfly, in addition to running it standalone in your SE environments. I talked a little bit about this. So in LL20D, I'll be talking Thursday about using CDI 2.0 in an SE environment. So because of that, this talk is going to be very heavily focused on the core as well as the EE ramifications to using CDI. I'll touch a little bit on some of the shared functionality that's out there, but that talk on Thursday is going to be focused very heavily on like the true core as well as the SE model around CDI. All of my material is available on my GitHub page. I forgot to put the full link to the repo, but if you look at the top of it, you'll see it as one of the bookmarked repositories on GitHub. So a few things around the new. First, the big one is the specification split. So starting with CDI 2.0, we are separating out CDI core, the core programming model around dependency injection and context management, as well as the SE components around it, being able to bootstrap a container programmatically, controlling the bootstrap, as well as the EE fundamentals around how to leverage this in your web applications and your messaging-based applications, anything you might be leveraging on an app server today. There were a number of event enhancements that we put in, asynchronous events, priority on events for ordering, the ability to programmatically build an event object, which was sorely lacking from the specification, giving you a bit more control over the true programming model. Another key thing is we've baselined everything on Java 8. One of the new features actually all the new features that you see were done in a backwards compatible way. Any interface that may have been implemented either by frameworks like Camel CDI, Metric CDI, we made it so that you can still use those libraries on CDI 2.0, even though we've built new functionality onto the core programming model. So similar to the Java 8 specification where default methods were used, we've implemented default methods in pretty much all the new all the new interfaces that have been added. Enhanced configuration capabilities and extensions. So one of the big complaints that we receive, not so much from the end user side, but from the library builder side, is the ability to easily create new beans without having to instantiate the 10 or 12 methods required on the bean interface. So we've built out the ability to configure those without having to implement the true interface. A lot of those are implemented using functional interfaces, so you'll see a lot of functions, consumers, suppliers in use, as well as some of our own functional interfaces that have been added. And the ability to apply interceptors to produced beans. So previously, you could create a new object, you can have a producer method or a producer field, but there is no way to do things like apply interceptor bindings. So we've come up with a way to allow you to specify those interceptor bindings automatically through an interface. So the key thing, really one of the first things that we tackled going into CDI 2.0 was the split out of the core programming model, the Java EE-based programming model, and the Java SE programming model, giving you the ability to pick and choose how much of the specification you want to leverage. Obviously, you don't get full HTTP request handling in the Java SE version of the specification, but you do get that core programming model that we have been applying. Java EE remains the full-fledged feature set, and this allows us to, at a later point, do things like a servlet-based implementation or a Java ME-based implementation, so that you don't have to rely on everything that might not be out there. Sorry? No, it's obviously with Java EE, you're getting the servlet specification, JXRS specification. All that integration is tied into the EE portion of this. The Java SE is really a lightweight, how do I bootstrap a container? How do I start and stop a request context? How do I apply asynchronous observers in a per executor basis? Yeah, it's pretty much the core CDI model with a little bit of things that we identified as being SE specific. At one point we did talk about splitting out into a separate SE jar and EE jar to make that clearer to the end user about what they were and weren't using. But we realized that it was two interfaces that would have been in the SE version. Everything else was coming from the primary core jar. Okay, event ordering. This, I have mixed feelings about this feature, to be quite frank. This allows you to order your observer methods that would have been called in any event that is being fired by your application. So if you were firing some POJO for auditing purposes, or you wanted to capture a login failure or login success type of event, you can leverage that through an observer method. However, there was no way for us to control which observer methods were being called in what order. By using the priority annotation, you can specify through application code, I'm going to call, well, really not on the caller side, but on the receiver side, I want to subscribe to this event with this priority on my reception. So if an exception happened earlier in the stack, you would never actually get that observer fired to you because it was already terminated prior to being invoked. I have mixed feelings about it because you're now putting very tight coupling between the observers that are being pushed out there. So I would caution anyone to be very wary about when you do and don't want to leverage this feature. Programmatic events. Previously, CDI 1.0, CDI 1.1, you had a beam manager fire event method. It allowed you to take any payload and just fire that event. There's no type checking. You could specify the qualifiers on that event, but they were never really looked up for you. Using getEvent now, you can build that fully functioning event object so that you can then chain through, go to the right type of object, go to the right qualifiers of that object, the same way you would with the injected event object. Where really we realized that we needed a feature like this to support asynchronous firing of events. We looked at adding a fire async method to Bean Manager, but it started to become redundant with what we were already doing. So we decided to introduce the ability to getEvent, informally deprecate the fire event method, allowing users to still use that, but encouraging them to use the getEvent object for the full-blown feature set. This is the only way that you can really control things like your executor service is going to be used for your asynchronous events, as well as giving you the clean programmatic builder interface of specifying qualifiers and types. To me, one of our coolest features is the ability to fire events asynchronously. So we never really specified it in older releases, but every event was fired and observed within the same bounded context. You had a request scope. That thread was inherently always the thread that received your event. We introduced the ability to fire an asynchronous event purposely so that it could be handled and not having to worry about the results of that event coming back to you. There is no programmatic way to get the result of an event. When it's been fired, you can mutate the input object. However, with asynchronous events, you now have the completable future to go through and look at what the result was. Sorry. So if you look in here, I've injected a regular event object. Can we get the font? Oh, shoot. Sorry. There we go. Better? Cool. So in here, we're injecting the regular event object, just like you would for any other use case, except now we're leveraging the fire async method, which takes in whatever you want as your payload object, as well as your notification options optionally. There is still a fire async that just takes the POJO for you, which returns back a completion stage so that you can do things like monitor the result if you're interested in seeing the result. However, you don't have to do anything with it. You can still do fire and forget on these objects. By using the notification options over here, I'm specifying that everything is going to go through a fork join pool that I'm specifying with parallelism of 2, allowing me to control the number of threads that will be executed. So if I had 2 observers, each one would be observed in their own thread. There are some downsides to this. So if you have an exception being thrown, one thread may receive it, the other thread may not receive it, depending on the order of execution. So you can also specify, you can also specify arbitrary options. It's kind of like a builder pattern for anything that's platform specific. So you can do things like tell Weld that I want to use a fork join pool instead of a fixed thread pool size. And Weld will take care of that for you. But unfortunately, that is platform specific. So it would be leveraging something directly from Weld or from Open Web Beans to bring in those features. The other thing about asynchronous events is if you look here, I have an async firing and an async observing. I have to define this as a contract. In CDI 2.0 and for any synchronous events that you would receive, I can define this. And in this case, this observer method is meant to be invoked synchronously, whereas this observer method is meant to be invoked asynchronously. This observer method down here, the sync receive method, will not be receiving this event because it does not support asynchronous events. It only supports synchronous events. I would have to do this. And now this event will get fired and received here, whereas this event over here will only be observed within the asynchronous receiver. I can still monitor it. However, I have no way of calling both receivers here. So you have to be very careful when doing asynchronous that you're ensuring that the client knows that you're doing asynchronous, and if you are the client, that you are correctly firing a synchronous or asynchronous event. No, so you specify the pool at the firing side, not on the receiver side. It's so another way to put it is you're specifying how the receiver is splitting off into multiple threads to send the events, rather than how many threads will actually be doing the receiving of that event. So we're effectively looking at it as asynchronous from the sender side, not necessarily asynchronous from the receiver side. Async events don't support priority. So one of the examples I gave a while ago is you can specify here the priority of this method. You can specify the priority over here, indicating that this should have a higher priority. However, asynchronous events don't support that because they're all going to be received asynchronously. We want to try to get to as many of them as possible. However, you do run the case that you may have caused an exception that caused one event to not get fired. It also depends on the executor that you're using. So even though I have one observer here, my parallelism is set to 2. That doesn't necessarily mean that all of my observers will get called at the same time. So if I added more methods here, 2 and 3, my parallelism is set to 2. It's going to wait until maybe this one and this one are observed before it calls this method here to handle the event payload that's come through. You also have to be very careful about mutating your event payload. There's nothing stopping you in Java from introducing a setter method here on this POJO. There's 2 problems that will happen here. One is that your set method could cause concurrency locks if you are synchronizing or not synchronizing. You're also not guaranteed which method is going to be called when. So as a result, you don't know what the final outcome of your POJO is going to be here. You could get into data that has been manipulated in the wrong way as a result of firing these in an immutable way. So be very careful when you're dealing with these types of POJOs that you're not mutating the payload or expecting certain mutations of the payload to occur prior to receiving the input. Your contexts do not propagate with asynchronous events. So if you're doing something like starting off from a JAX-RS request, which has a request context bound to it, you do not necessarily receive that same, well, you will never actually receive that original request context in the asynchronous event. So this payload over here, if this event was being fired from a REST call, a servlet, a JAX-RS call, there is a request context bound within the scope of this method. However, it is not actually the original HTTP request that was received. So you wouldn't be able to do things like look up the JAX-RS context for it or have access to any request context objects that were bound in the original request. It's always new. It's always meant to be asynchronous. There's no form of propagation of those payloads. You would have to build up a POJO here that actually maintained all that state for you. So if you are looking to use asynchronous, you need to create a very stateful object to pass over to that additional thread. Okay, so Java 8. Java 8's been out for 2.5, 3 years, I think. We're now aligning the CDI 2.0 specification to Java 8. Everything that you're leveraging within it has to compile to Java 8. You can't compile down to Java 6. In CDI 1.1 and CDI 1.2, those were effectively baseline to Java 7. However, they didn't actually require Java 7 to do any of their operations. So the implementations of those remained on Java 6 for quite a while. I think Weld 2.3 was the first one that actually required Java 7, and I think OWB 1.7 is the first to require 1.7 as well. However, going out of the gate, everything that is implementing CDI 2.0 has to baseline on Java 8. This does mean that libraries may need to get recompiled. Your application, if you're not already on Java 8, may need to be pointing to Java 8 to leverage it, but we are expecting that to be as part of the Java EE 8 specification. One of the cool things added, though, was the ability to inline configure beans. This is a very simple example where we're able to add a bean, where previously what you would have had to do is in I forgot to turn off something. So in here, in prior versions, you would have had to do something like this. Where you have to implement a bean with all of these classes, or all these methods already defined for you, even though for your use case, you didn't care about any of these methods. You can leverage all the defaults. We thought about doing things like creating forwarding objects that were default implementations for users, but when it came down to looking at what the true use cases were, it made more sense for us to allow you to introduce configurator objects, which took care of all of your baseline configuration, but still allowed you to override things that you really needed to override. So when I call add bean here, I'm getting back a bean configurator that tells, and I'm able to tell it when instantiating this object, produce it with this call here, which is it's a function taking in the instance. The instance object here is just allowing you to do some programmatic lookup if you need to, as well as destroying it, taking in the instance and the creational context, allowing you to do a very simple override of effectively 2 lines, where previously you would have had to do 40 lines plus of an implementation just to get to this point. We're hoping that it makes developer lives simpler, framework users' lives much simpler, and you're able to implement things very quickly. Next up, this is also Java 8 related, so the ability to stream your instances. Prior to the implementation of this, if I were to inject any private instance objects, I would have had to do something like stream support dot stream to get a stream object back. We're trying to hopefully make things simpler for the user. So now you can just do objects.stream, and you'll get back a Java 8 stream of all the instances of any given bean that you might have out there. So if you take the classic credit card payment processor example that has been used for years on end, you can now go through all of your payment processors and make sure that they're online. Just as an example, you can now go through and just easily loop through them, checking some method within each instance that might be out there. To me, the very easy use case is now you can do something like filter. Filter like O objects, non-null. Do some basic filtering of the objects, get back the right object that you're looking for, and as long as that is resolvable, you can then do real work with that individual instance, or you can go through and just loop through all of the instances that might be out there. Which led us to another feature. This isn't really Java 8 related, wasn't quite sure where to put it, but you can now do a very simple instance is resolvable method. Previously, you had to do things like if instance is not ambiguous and instance is not unsatisfied, which gave you very clear issues, like you can check to see, is it is there only one bean of this type available, or is it actually satisfied based on the resolution that I may have done? You can now check to see if that instance object is now fully resolved and do work against it. So if I did something like this, I now have direct access to the one and only bean that was identified through this instance object and able to do work against it. Also helps simplify a lot of your code. And also we support repeating qualifiers. So starting with Java 8, you can now put the same qualifier on an object. You can put the same annotation on a class, or you can put it on a method. In prior version of the specification, we explicitly forbid that. And now, starting with Java 8, because you can do it at the language level, we have expanded our support to allow you to have repeating qualifiers on your beans. This allows you to do things like specify that something is both a check processor and a credit card processor, and using the same annotation rather than having to create the wrapper annotation around the two. We're hoping it makes some things simpler for you, but obviously we want feedback. We want to hear from the users and get input on what is working for them, what isn't working for them. Any cases where you may have been using annotations in the past, you're going to want to be very careful as an extension writer that you are using the get annotations method in cases where you're getting qualifiers of a certain type. You can't guarantee any longer that you have a single annotation available to you. So you may run into some issues with some frameworks until they get caught up with this baseline version, adding support for qualifiers of repeating types. One case where I can think of that you might run into issues is if anyone's using Camel CDI, that may not give you the right implementation for all annotations. So now onto the noteworthy features. These are things that weren't necessarily added in CDI 2.0, but are very worthy of more talking to, more usage, to allow people to work with them a little bit more and hopefully find some benefits to what they're doing. So first is stereotypes, the ability to declare your own reusable annotations for different qualifiers as well as combinations of scopes and interceptors. Alternatives, the ability to override at deployment time what beans will and will not be used. Decorators, delegate patterns, and the ability to point back to some underlying implementation for your use case. All the different bean discovery methods that are out there, how to limit, how to control your deployment to reduce memory. How to work with unmanaged beans. So instead of having to rely on everything being injected, you can programmatically create beans on the fly. As well as portable extensions, the ability for you to control things that might be working in the deployment for you. I find stereotypes to be the most useful feature. I don't know if anyone else is using them this way, but to me, they help build out what your true business domain is in your application without having to rely on repeating 7 or 8 different annotations on every single method or every single class. It keeps your class very small and creates something that's very descriptive of what problem you're trying to solve. Obviously, though, these aren't built-in annotations that you're creating. So when I look at things like Spring and its use of the component annotation or the service annotation, those are things that the framework is providing for you. You're not going to find that in the CDI specification, but it should be up to you to figure out what your true business domain terminology is to pick the right annotations for your use cases. So I can create a very simple component annotation, which just says every bean annotated component is immediately getting the dependent scope type. This makes it available for discovery. This also makes it available as an injection point. I can also say that I want a service that is always application scoped as well as always transactional. So anything coming into this service will start a transaction as well as complete or roll back a transaction if it fails. I don't have to add these annotations directly to my implementations. I can just put them out there and they are ready to use. I can also set up things for testing purposes. So if I added a mock qualifier, or if I said that this was a mock service, I can add this to any implementation that might be part of my runtime for my test container. If you're using CDI unit, Archillion, Delta Spike test control to control all of your beans at test time, you can now manage them through a single annotation instead of having to repeat it over and over again. Alternatives allow you to control what beans will and won't be active as part of your deployment. They don't require you to make any more changes to your application structure other than making the, sorry, lost my train of thought. So alternatives are typically controlled in your Beans XML. However, you can control them through annotations as well. The Beans XML format was something we introduced in CDI 1.0. But its goal was to allow you to deploy based on that deployment descriptor, which beans would and would not be active. Anytime you were to inject this alternative, you'd actually get the alternative implementation rather than the original implementation for you. It's effectively doing swapping of your code without requiring any application changes. However, because of that structure, what it meant was your alternatives were scoped into that deployment archive, or your bean archive. So if you had a war file and 2 jar files, each of them with their own beans XML, you're now going to get different behavior within one jar file versus your main war file. So to fix that, we introduced the notion of global alternatives, the ability to specify a priority annotation at the class level to say that this alternative always takes precedence over any other bean that might be in the deployment. This overrode what was in your beans XML, and as a result made it so that you could use this at runtime and not have to worry about differences in behavior in your jar files, your war file, your ear files. And then decorators. I kind of think of these 3 as like the 3 cool, not oftenly used features of CDI, but it's the ability to just have delegates of your beans. Instead of having to rely on creating interceptors or creating classes that extend other classes and overriding which one was and wasn't used, it allowed you to go in and directly say, this is the default implementation. I need to add more behavior on top of that so that when I get into my use case, I can still delegate down to it to do some amount of work, but not rely on it for every single use case. So if I go here, I have some decorator, which just has one method, say greeting. I have a default implementation that just returns the word hello. And I have another decorator, the actual decorator class, which I've enabled by specifying the priority of it, saying that it's going to inject the delegate, which will be some other decorator, some implementation of this interface. And I'm saying that because it has the any qualifier. So this will always wrap whatever is being called. And overriding the method to say, even though the base said something else, I am saying goodbye. Allowing you to delegate some work down as well as build your own business logic on top of it. Bean discovery. Bean discovery is very confusing to most people. It's a very strong topic because of how featureful it is and how much it is and isn't controlled by what your application is doing. And because effectively with every release of CDI, we've made some changes to Bean discovery. CDI 1.0, you just needed an empty Beans XML. And what that meant was classes within this archive were discovered and you got no CDI functionality if there was no Beans XML file present. We saw that that was problematic for a few cases and wanted to introduce some new functionality. So when we moved to CDI 1.1, Java EE 7 first introduced that CDI is always on. As you deploy your application, your app server turned on CDI support for you. There was no optional feature anymore. Java EE was trying to adopt CDI as the core programming model, making it so that everyone could leverage events, could leverage the dependency injection features because of how widespread it started to be used. Prior to it, you had JAX-RS support, WebSocket support, servlet support. The more and more use cases came out, the more we felt that everyone was using it. Within CDI 1.1 and 1.2, we introduced 3 new bean discovery modes, which were only activated if your CDI version was set to 1.1 or 1.2, and allowed you to control whether every class was being discovered as a managed bean, only annotated classes with properly scope-defining class annotations were being discovered, or none, saying, I don't want any CDI support in this archive. We actually had to change what some of the default behavior was around this to handle CDI 1.2 because people quickly found out that their Maven deployments started not working when using Glassfish embedded with EE7. CDI 2.0 introduced 2 new concepts for you to use bean discovery. One is very SE specific. I'll be talking about that on Thursday. But also the ability to trim your archives, which is available no matter if you're using Java EE, Java SE. Trimmed archives were our answer to create something that was a little bit more than annotated, but not quite fully every single class that was defined within your application. We wanted to ensure that things that had some annotation on it that we had discovered were actually available as CDI beans, even if that wasn't necessarily what you were looking for. So we wanted to trim that down and say, we're going to look at all classes, but the only ones that we're going to consider as CDI beans have to have a scope, they have to have a qualifier, they have to be annotated as alternative, decorator, some sort of defining annotation on them to be picked up. So it made it a little bit bigger than annotated because we found annotated was too restrictive, but we also couldn't change the definition of annotated because of Java EE rules. And then Java SE with its own behavior and requirements. I'll be talking about that on Thursday. Unmanaged beans. This is really for the use case of having some object out there that you want to do some dependency injection into without it being available as an injection point. So any unmanaged instance that you might be working with is not available to inject into unless it has defining annotations. However, you can still instantiate it using CDI, using unmanaged instance to get a reference to it to work with for a short period of time. You have to go through all the standard CDI life cycles, which are called out here. So you have to produce it, which creates the instance, inject into it, meaning any injection point defined within that class gets satisfied by some other bean in the runtime, as well as call a post construct on it. So if it has a post construct method or a pre-destroy method, we do support the ability to call those lifecycle events, optionally if they're defined. Obviously, if they're not defined, we don't call anything on that bean. And then finally call get to get back that instance that was created through this chain. It allows you to work with that object for a certain period of time within the scope of maybe a method call or a succession of method calls until you're done with it, at which point you have to go back to the original unmanaged instance, pre-destroy it, and then dispose of it, making sure that you're cleaning up any dependency on that bean so that you don't have leaking instances floating around. Unfortunately, the contextual side of CDI makes it so that these objects are always managed. The bean manager is always aware of these instances that might be available and might be running. So you do have to make sure you're cleaning up after yourself. So this isn't a lot of code, but it's a lot of boilerplate code, at least as I see it. So I always find it very useful that if you are going to work with unmanaged beans, that you come up with some sort of wrapper around it. I like to joke around about the left pad too often, so this might make for a really good one-class library if you ever got to it. We'll see. But you have an unmanageable object here, which manages for you through an autoclosable the lifecycle of that object. You're always calling produce, inject, and post construct. You're allowing a user to get the underlying instance as well as destroying it automatically as part of the auto-closable chain. It makes it so that this lifecycle over here becomes a much easier to understand try with resource block to get you back that unmanaged object for whatever period that you need to use it for. Obviously, this only makes a lot of sense if you're using auto-closable and you can limit your usage of it to a single method, but to be honest with you, it's come in handy for developers who forget to close their objects and create some amount of syntactic sugar. So the last part of this is really talking about portable extensions. Portable extensions are effectively how we allow libraries to integrate into CDI. They allow you to go through, discover beans, handle any bootstrap events that you may want to do at the library level, as well as any application developer when we look at Java SC to handle the lifecycle of, do I need to start up a TCP listener? Do I have to publish an event out to my Hystrix, to some service discovery tool to say that I'm now available and ready to take events. The before bean discovery event is fired to a portable extension at the startup of a CDI container and will tell you that it is starting up. There isn't a whole lot of information you can do. For most of these events that get fired, you don't actually have access to the CDI runtime because these are in a pre-bootstrap state. You don't have any beans that have been discovered yet. You can't inject anything into portable extensions, but you can instantiate your own objects. Process annotated type is fired for every single class that has been discovered in your CDI container and will tell you what the class is as well as what some of the annotations are on it. Process annotated type allows you to do things like manipulate the actual runtime definition of that object. So if you have something annotated as request scoped, you can do things like check the type of class it is and maybe change the scope of it or add a transactional annotation to it at runtime. After type discovery allows you to look at just some callback event to say, I've discovered all the classes here. I can do things like add more classes at runtime dynamically to the container at this point that have been looked up through some other class loader. Maybe they're in a jar where CDI is turned off and I need to explicitly turn it on. Process injection target and process producer are fired at roughly the same time, and they are fired for every single class that has been found, every injection point within those classes, as well as every producer that has been found within those classes. So if I have a class with 3 injection points and 2 producer methods within it, I'm going to see that class come through 5 times, 3 for the injection points and 2 for the producers, to allow you to do things like manipulate those contents even further. Most of these events are designed for manipulation purposes, so you're either adding new things to them or you're removing something from them. Process injection point just looks at every single injection point defined within all of your classes to make sure that it is satisfied correctly and has a bean eligible for them. So every add inject that you see in there is available to you, and you can start to manipulate them. Process bean attributes and process bean are also fired. These are, process bean attributes is for the base class. Bean extends from bean attributes and just has some additional metadata from there. Process bean attributes is really for the underlying bean, whereas process bean is for the actual bean that has been identified by CDI and has been wrapped. You'll see this actually get fired in a circle between after bean discovery and process bean. After bean discovery allows you to add more beans at runtime. Every time you do that, it's actually going to go all the way back to process bean and refire that event for you. So this can end up into some weird endless loop where you're just constantly cycling through process bean and after bean discovery. You also have process observer method, which just gets fired for any observer that's been identified. It allows you to manipulate them in some way. After bean discovery also allows you to register additional observer methods for event reception. And then you have after deployment validation. So after everything is run and we've confirmed that the container is ready to go, the after deployment validation method is event is fired for you. This is a sign that the container is up. However, it's before things like the initialized application scope is fired, allowing you to do things like start up a web container programmatically before your application is ready to go. So it's one step prior to the actual runtime and ready to start receiving requests. So that's it. That's CDI 2 in a nutshell. It's a lot of stuff, but I'm hoping you guys enjoyed it. Any questions? So we just completed the public review ballot, I think it's called. That happened, I think, yesterday officially. All executive committee members who voted to accept. I think as of right now, the final draft will be available in April. There's a couple of typos and clarifications that we're still working through. So look out for it. The Weld 3.0 CRs are available, and they are generally up to par. And we obviously encourage people to use them so that we can start finding bugs and see where we've missed something in the specification, as well as come up with new features that we might need to add. Yep. Yeah, I'll be going through how to do that on Thursday. You can, if you are using Java EE, you can deploy to Wildfly though.
It looks like CDI 2.0 is the first new feature in Java EE 8.
Yep, that is true. All right, well, sorry. Thank you, everyone.